Hey, how you doing, class? This lesson we're going to talk about postulates and paragraph proofs. All postulate or an axiom is a statement that describes a fundamental relationship between the basic terms of geometry. Postulates are accepted as true. The basic terms were what we went over, which are points, lines, and planes. With just those three terms, which are undefined, we was able to come up with different postulates or different, honestly, scenarios. These are seven of them, and well, these are pretty much all of them, which were through any 2 points, exactly one line. We went over that. Through any 3 points, not on the same line, there's exactly one plane. Not on the same line, another word we can use for that is non-collinear. A line contains at least 2 points, correct. A plane contains at least 3 points not on the same line. We went over that. If 2 points lie in the plane, then the entire line containing those points lies in the plane, which is true. Remember, 2 points make a line, so that line and any points on that line would be on the plane if those 2 points are in the plane itself. If two lines intersect, then their intersection is exactly 1 point. If two planes intersect, then their intersection is a line. We went over those. And then also, too, for the notes for this section, is theorem proof, paragraph proof, or informal proof. Paragraph proof or informal proof is just two names for the same thing. There's two other proofs, which is flowchart proof and two-column proof, which I'm a fan of, and those are actually called formal proofs. A proof is a logical statement in which no, it's a logical argument, excuse me, in which each statement you make is supported by a statement that's accepted as true. In other words, like the postulates that we have, you can use those to set up a proof, or any other reasons which I went over before, like transitive property, reflexive property, or the definition of congruence are also logical statements that are accepted as true. Theorem is just a conjecture, which is a statement of conjecture. In other words, a conjecture is like the conclusion to an hypothesis in science, which has shown to be true. It is called a theorem. In other words, you've proven it, and it can be used as a definition or postulate to justify the other statements are true. We did this one, which is midpoint theorem. Midpoint, remember, the midpoint of a segment bisects the segment, and it divides it into two congruent parts, or segments as we call it. So in this case, if M is the midpoint of segment AB, then segment AM is congruent to segment MB. And by definition, the distance from point A to M is the same as the distance from point M to B by the definition of congruence. By me using the definition of congruence, that's basically using a statement that is accepted as true to support that AM is equal to MB, just to give you an example. All right, moving along. Here's the key concept that I wanted you guys to copy for proofs. This works for any proof. It's just like a little roadmap. Even if it's even if you don't understand all of it now, hopefully, because we're doing 4 sections, throughout the week, this will come a little bit more easier, or you'll be able to understand it as you go along. Basically, this is just saying that state the theorem or conjecture to be proven, which is the proof section of it. List the given information, which is the given section. If possible, draw a diagram to illustrate the given information. To me, the diagram is like the model. In other words, if they don't give you a picture, draw one, because that helps you. State what is to be proved or proven, and develop a system of deductive reasoning. Deductive reasoning is basically deducing, or in other words, based on the information you're given, what can you come up from it? In other words, I'll give you an example. Through deductive reasoning, I can say that since M is a midpoint of AB, then I can deduce that segment AM is congruent to segment MB. That's what that means in a nutshell. All right, this is all it is for 2.5, and thank you for watching.